Yes, so for today, let's move on to talking about how to fix some of the issues with sentence embeddings, or at least first we identify what are some of the issues. So firstly, if we just use the similarity encoding just by nearest neighbors, or just by neighboring sentences being similar and far away sentences being not similar, you have problems like this, like have, do not have, you will get quite a high similarity score. Okay, this is text embedding ADA 002. Jonathan was present, Jonathan was absent. You get a high similarity score as well. This is because in text, usually negation, although you might negate your sentence, it might still appear in a similar context to another sentence, even if it's not negated. So, like for example, Jonathan was present, he was in the room. Or Jonathan was absent, he was not in the room. So, this negation part could appear like with similar sentences. And so just going through the pure corpus of the internet, you may not get the idea of negation. So one thing that we discussed last week also is that like the newer models, the text embedding tree large seems to be able to fix this problem. Like have and do not have is quite a low score. And you can see for the rest as well, like Jonathan, present, absent, still quite high, but it's much lower than before. Before was like 0.9 if you look at the previous score. So it's much better now. Present, absent, they already have this. And what Richard and I were discussing is that this could be the reason why this happened is because they likely trained on the corpus that is self-generated, probably by GPT, to do negation. They might also do other stuff. Like I've tested quite a few, like A is the father of B, B is the son of A. They recognize all this stuff as well. And also stuff like that. A is bigger than B, B is smaller than A. Okay, so the newest model gets all of this pretty well. And I suspect that they might actually have trained with this data when they updated the embedding models. So unfortunately, because they did not release how they train it, we are not able to learn from how they did it. But this is what I believe they did. Okay, so the next thing I want to talk about is that embeddings, all right? You might think that they capture the entire sentence meaning, but it turns out that embeddings have this very peculiar property, or at least for OpenAI embeddings, is that if you have a very, very short text chunk, okay, the similarity is not as high as a long text chunk. What do I mean by this? If you look over here, you look at this text embedding tree large, all right? We have this sentence, John went to the supermarket, all right? And John went to the airport. Okay, the rest of the sentence is the same, like Peter went to the gym, Mary went to the garden. That's the same thing. The only thing that's different is the front part when I say John went to the supermarket or John went to the airport. But look at this. It's so similar, 0.92. Okay, similarity, the higher, the more similar. It's so similar because all these parts over here is similar because the back part is entirely the same. Okay, so what does this tell you? Okay, this tells you that for embedding similarity, if your text chunks contain almost the same text for a good portion of it, is treated as similar. Okay, a very, very high similarity. So if you look at we just talked the first part here, supermarket and airport, you can see that it's not similar at all. It's like 0.63, it's lower. So if you were to do embeddings, and if you were to have like a lot of similar text, like this is a very long sentence, and then you want to like embed like supermarket. Okay. And then you have another one, like this is a very long sentence that is similar, and then you embed airport. You realize the longer your sentence, the more similar the two embeddings are. Okay, anyone can maybe want to like think about like what are some of the issues with this? Like if we have a very, very long sentence, okay, but one part of the sentence is different, but the embedding becomes more and more similar the longer your sentence is. Can anyone tell me what problems can this cause?
And this is, you get inappropriate similarity. So it's a pigeonhole problem. Like it's got a name. If you reduce the information available, you'll eventually get inappropriate overlaps. Right? That's just what happens. And so as you're still getting one value out, no matter how much text you put into the embedding. So you implicitly throw away a lot. And proportionally, if you have longer texts, which are almost identical, then the impact of the differences is less and less as you go.
Yes. So this is again a problem with the similarity training, where we just train like similar text to be like adjacent to one another and non-similar text to be further away, is that you don't really have you can't really control what goes into your embeddings. And so what they have learned is that they learned that if your text chunks are more similar, it means that they are similar in terms of embedding score. Like, so this is actually a very understandable or like quite an intuitive way to group similarity if you think about how it's trained. Because if we train two sentences next to each other have high similarity, the chance of you having similar chunks in two adjacent sentences is quite high. So the model actually learned the right thing. It's just that for our use case, if we want to do like text chunks, if you split your book into chunks, for instance, and each chunk of the book contains the same way of starting the sentence. All right. Like for example, the book could say that on a very hot summer day. I mean, if every single paragraph of the book contains on a very hot summer day, all the paragraphs will be like considered quite similar because there's this similar chunk. So it's an artifact of how the model is trained, because we are going by sentence similarity by the position of your sentence in like the training in the training text. So this means that if you want to compare embedding similarity, it might be better if you already can extract the right entity you want to have. Like for example, John, you can extract out the entity, okay, get the specific part of the sentence with the entity, okay, and then compare your embeddings. This might work better. Okay, this is actually better than compare embeddings of entire sentence. If you think about it, it makes sense also, because okay, if you look at this, for example, if your sentence contains an embedding here, so the part one of the sentence, the embedding is here. Part two of your sentence, the embedding is here. And part three of your sentence, the embedding is here. How do you want the model to group the overall, and also maybe part four, the embedding is here? How is the model going to group the overall similarity, right? You're just going to average out everything here. Yeah, and so if like one of your parts is like a very, very long part, okay, what will happen is the similarity will get drawn towards that part. So for example, if my one is the influencer, it's like super huge chunk of text, it draws all the embeddings towards it. You realize that although your 2, 3, 4 are different, all your embeddings might end up being in this area here, and so have high similarity as what we see here. In this case, the text chunk number one is this one. This is text chunk number one. Peter went to the gym, Mary went to the garden. It draws all the similarity towards it. Okay, and this means that whatever you want to compare, like John went to the supermarket or John went to the airport, gets lost because the other chunk takes away all the similarity. So I think this is not so much a problem with the way like sentence embeddings are, because I think if let's say you only have a binary or have a single dimension output, this is a fair result. Okay, I mean, I can't expect anything more, anything less. This is a fair result, because right now, although I want to compare what John did, but the fact is that we are comparing sentence level. And sentence level, if your sentence is very, very similar in this chunk at the back, it's only fair for the sentence embeddings to be similar. Okay, what this is, however, a practical issue with retrieval augmented generation when you have very similar text chunks. Okay? The thing is, if you don't extract out what's relevant in that text chunk for what you want to do, you will end up having very high similarity. Okay, so this is a practical issue that I faced when I did retrieval augmented generation as well. And I went to figure out that the root cause of the issue is this. The more longer your text chunks are that are similar, the more similar the embeddings are. Simple as that. Okay, any questions or any comments you'd like to add to this slide?
Hey, John. So when you did the testing, you were testing long sentences. Do these long sentences have more complex meanings, or they're just long?
Just long. So if I give a random series of symbols, it will still work as well.
Okay.
Okay, I didn't exactly try out random series of symbols, but I tried out meaningless text. Like, for example, if you put like lorem ipsum over there, it will still work. Like it would basically compare, because the tokens for that very similar text are the same for both sentences, so they will just treat it as more and more similar, which is a fair conclusion. Yeah.
So from my experience, ChatGPT does pretty well with English poetry, right? Because it's very short. But it completely missed the mark when it comes to, like, some of the Tang Dynasty's poetry, because those poetries tend to have multiple meanings. So the finding here is more specific to English, right?
Yes.
I'm not sure it's true. When I looked into, I haven't done this for a little while, but just in general, long form writing, the LLMs are terrible at, as a rule, right? They are all bad at long form writing. And in terms of multiple meanings in poetry, I'll keep out of that. I'm not much of a poet. But in terms of just working on longer form, that's really just a thing they struggle at. Like the context starts falling apart and so on and so forth. So I'd say it's more the content size. Like if you gave it like an epic poem from translated out of Greek or something like that, the Odyssey or something, right? And they're going to struggle just because it's a lot of text.
Yeah, actually, that's a problem with positional embeddings as well, because when you do positional embeddings in transformers, the position embedding gets added to the token embeddings. So this means that there's a, like, in order to discern your position here, you have to kind of know what's your token and like try to decipher where it is. So it's not a perfect way of finding out like what this is, because usually a position embedding is like some sine or cosine wave. Yeah. So it will go into all dimensions, and this will affect your token embeddings as well. So this is a graph I have about transformers. And I mean, it works okay for short text, because short text, maybe you can discern your position quite well. But the longer you go, your frequency increases for your position embeddings. And it means that it's harder and harder to tell what position it is. So like, I would say that as a rule of thumb, most LLMs work well only within 2K to 3K tokens. You go beyond that, the position embedding is just not encoded well enough. And this is an inherent issue with the architecture. So how to solve this? To be honest, I think we need to go back to some form of like RNN kind of generation, where, you have a hidden state and then you just propagate this hidden state again and again. Then you might solve the position issue. Okay, but if you solve that position issue, you will have issues with information bottleneck, because when you have this hidden state and you keep passing through the hidden state, like RNN pass through from one unit to another, you lose out the information of the first few tokens. Yeah. So this is a hard problem, because if we want to do a combination of both RNN style hidden units plus the transformer, we will need a much larger architecture, and also we need an architecture that allows for, like, you can't do all tokens at one time. So right now, when we do the transformer architecture, if we go back to this diagram, right now we feed in all the earlier context tokens at one time. Okay, if you want to talk about the RNN architecture that I was talking about, like you have your RNN here, let's put it R. You have a hidden state here for every token. So this is token 1 goes here. And then you have a hidden state goes here, token 2 goes here. So if we were to do something like this, and then your hidden state here, okay, perhaps you could do a modification. You could also have your token come here. Okay, but the thing is, if we do something like a recurrent way of doing things like that, your position will be encoded much better. Okay, let me just write this down. I believe that if you do a recurrent structure, would encode position much better than positional embeddings. So this is my hypothesis, but it will incur runtime issues, because you will need longer time for inference. You need to keep putting one token at a time, pass it through the model and do the recurrence. Okay, it's not as fast as what the transformer can do. You can just do everything in parallel. All right, right now. So the transformer architecture was really designed to harness the powers of GPUs. This kind of recurrent structures will be slow. All right, they will definitely be slow. But it can probably do much longer context. And yeah, so the issues that y'all have mentioned that a longer sentence doesn't do as well, I think that's a general issue of transformers. It's not specifically for embeddings, it's for transformers itself because of positional embeddings. Yeah, so yeah, any comments on that? Okay, if not, I think that was a great discussion. In the interest of time, let's move on. All right, so this is how retrieval augmented generation is typically done. What we'll do is we'll encode a sentence into an embedding space using an embedding model, like for example, the OpenAI text ADA embeddings. And then we take another sentence and then we embed it into another embedding. And then we do a cosine similarity to see whether or not the embeddings are the same. The more similar it is, the higher the score of cosine similarity. Then in the end, what we'll do is we'll pick the top K documents that have the highest cosine similarity to your query. So this is how it's normally done. And with the issues that we have identified earlier about how, the longer text, your similarity is the same, how the sentence embeddings are trained using contrastive loss and may not capture all dimensions of what you want to compare. There are some issues with these embeddings, and this means that whatever you get for retrieval augmented generation can be bad as well. So it depends on how similar your use case is compared to the objective of the sentence embeddings, which is the contrastive loss based on adjacent sentences. If your use case suits that kind of loss function, then this cosine similarity based on the two embeddings would fit quite well. But if not, if let's say your use case is something a bit more specific, like you need to go by entity like this, then just using naive text embeddings won't work too well. Okay, we might need to do something like some papers are recently exploring like multiple hierarchies. Like maybe you could summarize information or you could extract out by entities, put into knowledge graph. You could do something like that to improve your embeddings. Yeah, but there's another way that I found quite interesting, and that way is called not having embeddings at all. So what is this? So this is basically a way that Cohere Reranker uses. They train a model that takes in both the query and the documents all in the same model, and then outputs a cosine similarity. So what's the use of this? Okay, the use of this is that you don't have any more like contrastive loss to learn sentence embeddings. Okay, no, sorry, that's not true, all right? Because your contrastive loss is still here. Don't have any more need to split, to lose information from sentence to embeddings. You can just feed in the entire sentence and then ask it to output a cosine similarity. So as a case in point, this is what is like what you can do in ChatGPT. So in ChatGPT, you can ask like, are these two sentences similar? They put sentence A, sentence B. So I mean, what Cohere did is not like that. What Cohere did is they trained a model from scratch using your data, and then you can label your data as having positive pairs or negative pairs, and they will train this model for you using the Reranker that they have. But if you do this without training your model from scratch, you can also do it in ChatGPT. You can just type in like these sentences, are they similar or not? You can even put a score here. So the score is like 0, not similar at all, and 1 is a similar entities, different context, and number 2 is maybe like all similar. So you could ask ChatGPT to give a score like that, and then you could get your similarity rating. So the more categories there are, you can get a more distinct comparison of similarity. And the benefit of doing this is that, we were talking about multiple domains earlier, right? Can easily be done by ChatGPT-based classification. So it may be possible to, if you use this method, you don't even need to train the embeddings to be performant because there's no embeddings here. I mean, the embeddings in the model itself, but there's no, like, for example, here, there's no embedding A and no embedding B. Everything is done in the same model, and then you just output something. So the output could be a cosine similarity score, or you could output your own stuff. Like you could output text describing the similarity. You could output like a classification score. on multiple domains of similarity. So there's a lot of opportunities here, and I think this is actually way more performant than embeddings, because you can actually use GPT to understand the whole sentence better. So like if you have different contexts and so on, if you pass both sentences in, the LLM itself is able to better understand the context given the full sentence. Okay, it's quite okay, the more intuitive way to understand this is like this. The way we categorize things into embeddings, okay, something like you tell your kid, okay, you drop the ice cream on the floor, that's bad. Okay, you don't tell the kid you drop the ice cream on the floor. You just say that's bad. Okay, when you see your kid drop the ice cream on the floor, you say that's bad. When you see your kid read a book without tearing the page, you say that's good. The thing is, we don't really have a very high dimension feedback to the language model saying that why is it good, why is it bad? Or in this case, why is it similar, why is it not similar? Okay, but if you feed in both instances, like kid drop ice cream on the floor and kid reads book without tearing pages, and then you can get similarity score is like not similar. So if we do something like this, where it's a more end-to-end thing, you just process both the key and query jointly together and output something, you will get a better understanding of both sentences because you don't lose any information before you do the model processing. Okay, so why haven't we done this? All right, why haven't we used this in practical RAG systems, right? The problem is, although you don't have any lossiness, don't have much lossiness when you generate the sentence, the problem is every single query and document you need to pass through the model one time. Okay, you need to pass through this to the model. Can you imagine that? If you have 1 million documents, okay, and you have one query, you need to run the model 1 million times. Okay, for each query. Okay, can you imagine such a system? Okay, it can be quite expensive. All right, so
that's the wrong term. It's expensive. Not possible. It's not that it isn't possible. It's really expensive.
Yes, correct.
Yeah.
So I think this will solve a lot of issues with embeddings if we can do this at scale, cheaply, which will be possible in like 1 to 2 years. Okay, then we won't be talking about embeddings anymore. We'll just be doing this method where you do the combined model processing. It's way better. It performs well on almost all the things I can think of, because you can do this multiple domains thing. Okay, you can just ask it to classify a score, not just one score. You can classify many different scores based on what you want. Yeah.
Hey, sorry, John. So I'm trying to understand. Sentence B is the whole document, and sentence A is the query.
Okay, so in this case, it depends on how you define it. Like for example, Cohere Reranker, sentence B here will be like 20 documents or like a selection of documents, and they will basically do one-time processing to get the similarity scores for all the documents. But in this case, to keep things simple, we can just treat sentence B as just one document. Yeah, just was one index in your database. So you just, in the model comparison, you're just comparing one query to one document. Yeah, I mean, just for ease of discussion, you can just treat this database part to be just one document itself.
And the query, what does it look like?
Oh, okay. The query could be like that. What is the meaning of life? Something like that. Then the database document maybe like the meaning of life is 42. Yeah. So something like that. In practical use cases, the query would be something like that. The database document will be a chunk in a book. Like it will be a paragraph or multiple paragraphs, depends on how you chunk your text. So that's how it looks like in practical use cases. And what we want to do is we want to match your query to whatever you have in your database so that you can retrieve relevant contexts to do to basically to augment your query. So basically, if you ask like what is the meaning of life? If you can find out that the meaning of life is 42, you can put like that in so your context is the meaning of life is 42. Then you can ask like, what is the meaning of life? Can you see that? If you ask ChatGPT something like that, you will get a better answer than just asking what's the meaning of life directly without giving the context. So in some sense, this similarity score to find out the documents from your database is to help to improve the context to the large language model. Is
Oh,
that,
I see.
yeah.
Oh, I see. So what you're saying is that I can have multiple domains, and that multiple domains will be another domain sitting on top of sentence B. That could be your situation where you are. I'm by the beach and I'm asking what's the meaning of life. Are you saying that?
No, doing the multiple domains thing is basically asking it like whether is it similar or not. So maybe one of your domain score could be like this. 0, same location. Location not same, not similar. 1, location type is similar, exact location is not. Then maybe 2 is exact location is similar. So you could easily create a domain score like that, so that in your query and your key, you can see whether or not the location is the same. If both of them are at the beach, then this score will be 2. If one is at the beach and one is maybe at the lake, then it'll be 1, because it's like similar but exact location is not. But if like one is in the sky and one is in the beach, at the beach, then it'll be 0 because it's not a similar location at all. So you can do metrics like that. So if your use case is talking about location, you can do a domain score for location. If your use case is talking about entities, you can do a domain score for entities.
Okay, all right. So if I were to give you another domain, like I asked, someone asked that question just after they had a fight with their spouse. So how would you lay them out there, just like the one that you did?
Okay, what do you want to compare? What similarity category do you want to compare?
Well, it's the context, right? You want to compare, someone's different responses, or incline of different responses of the meaning of life, comparing before they had a fight with their spouse, or if they hadn't had fight with their spouse, right?
Or you want to
So
put
for most people,
you want to put the context in the query itself, is it?
yeah.
Yeah, that's possible. So that means what will happen is that given this context, the LM will interpret the similarity differently. So like before having a quarrel with wife, maybe your meaning of life is like better, is like happier. After you had a quarrel, your meaning of life is maybe a bit more sad. You can match accordingly to the documents according to this context. Yeah, I think that's possible.
Okay, perfect. Now I understand how you explain that different domain. Okay, perfect. Thank you.
Correct. So this is actually easier to do than if we were to do it on the original transformer itself like that. Because can you see that because of the issues we had for sentence embedding, can you see that this embedding may not be as expressive? Okay, this embedding here may not be as expressive. So if you lose the information already when translated, you cannot get it back. All right, so this is the problem with sentence embeddings. Again, it must be asking me like, if this is so bad, why are people using it? And as with most businesses, the key bottom line is what? It's profits and costs. This costs a lot, right? So if we can deal with a little bit of lossiness, okay, at the benefit of gaining more cost, using less cost, then maybe you will use the sentence embeddings directly. But if your use case can bear the latency, can bear the cost, this is strictly better. This is much greater than cosine similarity on embeddings. It's hands down, this method is much better than cosine similarity on embeddings. So you should use this if you have very few documents to compare to. You should just use this. Okay, if you use the embeddings, you'll be bound to lose out some information. So I cannot emphasize more because I've been using something like that for quite a lot of use cases already, and it works much better than just doing embedding similarity. So, yeah. Any questions before I move on to the rest? Because the more juicy parts are coming up after this.
So to use this method, that means that you have to re-architect the whole large language model, right? You have to retrain it.
Correct. So for Cohere, they actually did their own transformer that takes in both the query and the key and outputs like a similarity score. So how they do the similarity score, maybe it's an MLP, multi-layer perceptron, or it could be a ranking like what I did. Yeah, I don't really know because they didn't release their model. Unfortunately, closed source is like that. But I do know that they put in both the query and key into the same model because one of their spokesperson for Cohere did a video on it, and that's how they describe in the video. So this is something that I like a lot. You don't lose out anything before by passing it out into an embedding. You just store the entire sentence and all the tokens for both the query and the key, and you process them jointly. That retains all the information. But what I'm saying is that we can do better than Cohere Reranker. We can even use ChatGPT directly to do the score by just prompting it. You don't even need to train your own model. You could just prompt ChatGPT to do the model similarity comparison, like what I said earlier. Compare these two sentences. Maybe I write out again. You can just ask ChatGPT like that. Classify if the two sentences are similar. Then you can just put like sentence A and then sentence B, and then you can put your score criteria 1. Then you can just give the criteria here, and you can give like score criteria 2. Then you can give the criteria here. So it's very flexible. So instead of just outputting a cosine similarity like that, you could even classify into your own score categories, and then you can just like maybe use regex to extract out the scores, or use strict JSON. Yeah, because strict JSON can do this for you directly. Yeah, you can just output the score criteria out into a JSON key, and then you can just extract it out in the dictionary. So all these use cases very easily done with strict JSON, and that's the framework that I'm creating.
So tell me if I'm wrong. That really means that if I have two different organizations, I can actually train my own model for two different organizations, and because sentence B are different from each other, they actually get much closer answers when they ask questions within these two organizations. Is that correct?
Yeah, if your sentence B is augmented with, or rather if your query is augmented with the specific organization you have in mind, then when they do similarity classification, I mean, one of your scores could be like whether or not the organization is the same. You could put it, you can put that here, then it will be similar. Yeah.
Oh, wow. Okay, that's awesome.
And the good thing about this is that you don't have to train at all. No fine-tuning needed. Okay, you just prompting. So very, very efficient. You can just tune it to your use case without even needing to fine-tune anything.
I think I'm sort of challenge that a little bit. That's the awkward thing of, I'd call this a prompting-based technique, right?
All right.
The problem with prompts is that they don't have consistent behavior over time, and they need to be tuned for a particular model and so on. So they're from my point of view, they're quite fragile. It's not that this approach is bad. I think it's a great approach, but it's just the nature of prompting-based techniques is they're fragile. They break easily.
That's true. So when you use prompting-based approaches, there's a very big caveat. The caveat is that your use case must be similar to the internet's corpus of data. All right. If let's say your use case is very different from what the internet has to offer, then the baseline knowledge in ChatGPT would counter what your use case would need. And this might make using this prompt-based technique problematic, and you might need to just train your own model directly, like something like Cohere Reranker, or just train your own large language model directly for your use case. So you know, there's a paper that recently came out. Also, they say that large language models don't generalize beyond the training data. That's kind of true. If it's a combination of the training data, transformers can handle it well. But if it's totally outside of your training data, transformers don't do well at all. So just bear this in mind. Yeah, I think what Richard pointed out is a valid concern.
But that's a good thing though, right? Because right now, if you look at the large language model, it has embedded a lot of biases that you cannot get rid of. And then they try to provide, guardrails, around it, and that created more problems because you're trying to make an apple into an orange on the surface.
There's actually a way to counter these biases, and that way is called specificity. Like for example, in the scout criteria 1 and 2, if you just say that just talk about person or talk about objects, even though you might have biases in the training data, if you just talk about entities, something that is more objective, you might be able to counter the biases. I say might, okay, because sometimes it's impossible to get rid of biases like spelling biases. You can try this very interesting use case. You can try to spell something wrongly to ChatGPT. Okay. Like for example, hello world. Like it's supposed to be hello world, right? But you spell like that. I realized that the ChatGPT will correct your incorrect spelling for you. Like hello world become hello world, even though you didn't ask it to. Yeah, so this is a bias that it has. And the bias is because we assume that people type words correctly. All right. But if let's say you want to create a chatbot that purposely types in incorrect letters, you're going to have to counter that bias a lot. And you need to say that something like output exactly without correcting, or you can just say that we intentionally output misspelled words. Yeah, you must say something like that to counter the bias. So this is to counter bias. So it becomes a bit harder. If you have a use case that doesn't need to counter the spelling bias, you don't have to say this at all. But if you want to counter bias, you need to perhaps prompt it a bit more. Yeah, okay. So I think let's leave it as that because we still have a few more slides to cover. Let's move on. So how can we actually get the embedding space to improve? Okay, let's suppose we don't go by this method where we combine both the query and key because it's expensive. How can we get something that is cheaper by just using the embedding itself? And one way, okay, a few ways that I found out, okay, this is what interests me. Okay, this is called hypothetical document embeddings. And what is done is that you have a few instructions, like for example, write a passage to answer the question, write a scientific paper to answer the question. Well, over here, they illustrate for different queries, but you could do that for the same query. So your same query, different instruction. Okay, and what will happen is that we ask a model to generate out hypothetical documents. So these documents are fake. Okay, like for example, you ask it to generate a passage to answer the question, it's fake. Okay, it's synthetic. It was totally generated by the large language model. But the embedding space of this document could be more similar. The embedding space or abstraction space of hypothetical documents could be more similar to the database. Okay, because why? Okay, this is a very interesting approach. Because the way you ask questions and the way that you get the answers from your database can be of a different embedding space. Because you see, the question is like maybe like, what is the meaning of life? All right, and then the passage is like, from the blah 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 blah, the meaning of life is 42. I mean, you think about it, the query is much shorter. That's for one. Okay, query is much shorter. The document much longer, contains more redundant information. Can you see that the abstraction spaces between both of them, both the query and the document, is quite different, right? If we were to use the same embedding to embed both the query and the document, you might end up with a space of embedding that is quite different from what you actually intended to. And what does this hypothetical document embeddings do? Because they ask GPT to generate out a hypothetical text, essentially we are shifting the embedding space. We are doing a sort of a mapping of the embedding space into the document embedding space, which makes the retrieval better. So they actually have 20 percentage points gains over the method that didn't use their method. So they use the contriver, which is like something like the it's just a way to compare to generate embeddings for text. So they use this with and without their method, the 20 percentage point difference, which is huge, is super huge. In fact, it just shows that embeddings, if you generate them in the same space, in the same abstraction space, you will get much performant embeddings as compared to comparing embeddings of two different spaces. So the key insight that we get from this is, maybe we should map our embeddings to make sure that the embedding space are the same between the query and the documents. So I like this idea a lot. And how did they do this? They use an instruction, okay? And this instruction cues them to generate different kinds of passages. What they did here is they actually average out the embeddings. and then use this to find the document. Okay, so if you all been for my first part, I don't really like this approach of averaging out embeddings. I actually don't like it, because if you average out very different embeddings, you will get very different answers. Like you have here, 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 the embedding space. You average them out, you get something in the middle, which is not very informative at all. So maybe the way that they could have improved their method is, instead of averaging out embeddings, is to take each embedding and find the relevant documents. Yeah. But the idea behind this is a great one. Map your embedding space from the query into your document space. Or I mean, if you could have the document, you can map to your query space. I mean, there's also, I think the paper is called Hypothetical Questions, but I couldn't find that paper. But the idea is like give questions to the documents. So if you could map the domain space from the query to the document space, or the document to your query space, you might get more informative embeddings. And this could go very well in line with the sentence embedding objective. Okay, if you take a look at the sentence embedding objective again, you will see that neighboring sentences are similar and non-neighboring sentences are not similar. So if we can map it out to the same space, like in the document space or in the query space, you can see that this objective will be met more easily, right? Because if you map to the document space, the chances are you can find very similar chunks of text that belong to that kind of objective that was used in the training. Right, questions on this? I think this is a very important slide. All right, so this idea of shifting your embedding space into something that is closer to what you're comparing to is very important. Okay, I'll highlight this again later. The other paper that I was quite excited about is this by Recitation Augmented Language Models. Basically, similar idea. You have like a question you want to ask. You give some hints. Like these hints are actually pre-trained, like maybe using Wikipedia, because like the Wikipedia headings, okay, and then you can give the paragraph. So in some sense, okay, they probably use more than Wikipedia, but Wikipedia is one idea whereby like you could get a potential like this is your passage hint, okay, child support or child benefit, and then what will happen is, like based on this passage hint here, okay, you will identify a certain paragraph that fits it. So given this question, okay, they actually fine-tuned a model to find out from this question what is the passage hint I should get. Okay, then from this passage hint, they just extract out the entire document based on like the header of the passage. And this, okay, we don't have to do the method like them because it's a bit complicated. Hi, can you hear me?
Yeah, can hear you.
Yeah, you can hear me, right? My video froze, so I'm not sure whether.
Now you froze. Oh, there we go.
Yeah, the internet has some issues today for some reason.
Yeah, we hear your voice, but not seeing you. That's okay.
Okay. Yeah, no worries. We'll do without the video for now. So the idea is that we actually have a way to map, okay, using the hints, okay, we can actually recite different parts of the paragraph, like different paragraphs here. Okay, and we can generate skewed output. Okay, we don't have to follow what the paper did with all the pre-training. Okay, no need to follow pre-training steps because I think it's very complicated. But the idea that I want to bring across is that we use hints to skew model output, use the diverse outputs to answer questions. So again, what does this do? It maps the question embedding. You can see what maps question embedding into a similar abstraction space, as this. To maybe the in this case, what they actually did is they map similar abstraction space to the actual passage itself. Okay, so that you can answer it. So in some sense, it's slightly different from the hypothetical document embeddings, okay, because we don't take the embeddings of this passage. What they actually did is they just use this idea of sampling diversely, all right, in order to just use one language model to answer the question. So there's no embeddings here, no embeddings. LM answers the question with augmented context. So the idea of this is basically using different hints, you can sample different contexts. Okay, I mean, you might be asking me, you know, like, why do we even need the hints? Why can't we just use a normal like embedding similarity to get your passage? Okay, the key reason is because, you know, if you just use embedding similarity, you might lose out certain stuff. But if you use something like passage hints, okay, you might be able to guide the large language model to sample the right things. So I think this is an idea that goes into the next part, where you can have context-dependent selection or context-dependent embeddings, where you can use your context to guide the large language model to like change maybe the query into something else. Okay, so just bear this in mind. Okay, I don't really advocate this whole approach because it's very hard to train this. But the idea of hinting is something that is useful, okay, in order to guide the large language model to generate something differently. Okay, questions for this?
Would this work better with robotics? Like, you know, with different kinds of sensor that, you know, give different hints, and then, you know, based on all these, you know, outside feedback coming in, the robots can actually respond better?
Yeah, maybe. Yeah, this actually is a way to do like multiple generation and sampling actually. I think this might work for simulations of robots. Okay, not exactly the real world itself, because you can't generate multiple actions to try the real world, but at least in if you talk about in the kind of use case of a simulator, this might be able to sample various action spaces in different domains. Yeah, so as you can see for this passage hints here, they sample different things based on the different domains as well. Like for example, child benefit, based on the pre-training, they identify these are the relevant headers that are needed. And, you know, similarly, you could have some model to pre-train such that, you know, given a certain task, these are the first few actions you need to explore. There's something like, you know, Alpha Zero, you have a policy network. You could train a network to identify promising moves. So in this case, this is your exploit in reinforcement learning. Yeah. So I do think that what you said could potentially be like used in robotics. It's just like you need to do it in a simulator. You can't do it in real life.
Yeah, correct. Mm-hmm.
Yeah. So this idea of using diverse hints to get various abstraction spaces, I like a lot also. Okay. Is different from hypothetical document embeddings. You don't map it directly to your document embeddings. Okay, although you could, because like honestly, if you think about it, this could also go into, this could actually be document embeddings as well. If you think about it, it's just like these are the actual documents already because of the way they did this. Okay, but that's not the point of this paper. The point of this paper that I want to show you is that you could provide instructions to hint the large language model so that it outputs something in that domain. So this is your original domain. So this is your original embedding domain. This is your original domain. You can hint it such that it goes into domain 1, domain 2, domain 3. So it samples from a diverse lot so that the chance of one of them hitting your actual use case or actual document might be higher. Okay, this is what we get here. In the hypothetical document embedding paper, we have the query space and we have the document space. And what we are doing is we are generating a space D prime that goes closer from the query space to the document space. So these are two different approaches. Okay, this is hypothetical document embeddings. And then this one is the recitation augmented language models. Okay, I mean, you can think about it. If you look at the prompt breeder paper by DeepMind, they also do something similar. They have an instruction to guide the language model, say, make a prompt more into this direction or more into that direction. So by giving different hints, you get different output generations, and you also change your output. By changing your output, you change your embedding space as well for the output. So this idea of mapping something to change the embedding space, powerful. This idea of mapping your embedding space to go more directly to your domain embedding, that's also very powerful. Okay, now let's move on to the experiments that I have. Okay, we have about 10 minutes more. So the idea that I have is context-dependent embeddings. How can we change the embedding meaning just by prepending a context or appending a context before we do the embedding? Or can we modify the text chunk itself based on the context? All right. So this context can be like one of multiple categories, like what I said earlier, like person, action. Okay. And this makes the embeddings very flexible. So instead of just having only one embedding for each text, you can have multiple embeddings that cater across different categories. So this is the example I have. Let's just use the riverbank as an example. So I went to the bank. It could be a riverbank or a financial bank. And I went to the river. So you see, Barrett Bank, because it could also be riverbank, it should be a high similarity score to I went to the river. But because of biases in the text, bank is usually financial bank. Okay. So it doesn't have a high similarity. You can see over here. Okay, but financial bank to get money, I think high similarity because that's how it normally appears in the text online. So if I just append a context at the front here, like context water, okay, I want to see whether this increases the similarity. And yes, it increases the similarity of bank and river. That's great. But you see a problem here. If I append the context to the financial bank situation, I'm not supposed to get an increase in similarity because this is water, you know. In fact, this is supposed to be not so high in similarity. But you see the similarity here increase. Okay, and this is because longer chunks of similar text have similar embeddings. So prepending context works to a certain extent, a limited extent, but it doesn't work fully because if you expand your context, you might risk the fact that all your embeddings become more similar. All right, so this idea of changing the embeddings to embed this context at the start didn't really work out too well. Right, I also tried another approach because after last week's session, I was saying that, you know, what if you could make your token embedding say like, oh, I want to summarize this sentence, and then you try to make the token embeddings more closer to the sentence embedding by just like hinting that you want a sentence level summarization. All right. This kind of didn't work as well. Okay. I mean, yes, it increased the similarity score for water. That's great. But you see, it also increased the similarity score for bank and money. So the problem is having this entire chunk here tends to increase the similarity too much. And this is not a good approach. Okay, so the idea that I had of changing the embeddings based on context, I think just using this method of prepending or appending wouldn't work out too well because the longer your embeddings are and the more similar words it has, it just naturally becomes a more similar embedding. So then I thought about it, you know, like how then can we have the context infused in the embedding, but we don't add so many words, right? So that's my last experiment, and it has been quite successful actually. So I intend to test it out in real world use cases, but I'm just sharing it here in case you all have any ideas to improve it. So instead of, okay, this is the original text. I went to the bank, I went to the river. So I map the context here of water over here, and then the bank becomes river bank, and the river becomes river. So how did I do this? I just did a simple prompt by ChatGPT. Okay, I just fed it the context is the water. Refine your text based on context without changing the text meaning. Some parts of the text have more meaning based on context. Highlight those. If unable to refine, output original text. So essentially it converted I went to the bank to I went to the river bank. So you can see that there's an embedding space change. And this embedding space change based on context can help us retrieve similar embeddings of that context itself. So, you know, while my initial naive idea of just prepending and appending the context didn't work out too well, we could perhaps use GPT to just change the embedding directly based on the context. And you can see that you see the similarity for this. The similarity for this is 0.87. Very good. Very good. Very good similarity. And if I make the context water, I change to I went to the river bank. I went to draw money. Because of the word bank changed to river bank, already the meaning has changed in the embedding. And you can see the similarity for bank, for river bank and draw money is very low now. So embeddings work well when the tokens reflect the context already. So we shouldn't try to like feed in more context to let the embedding interpret the tokens because you increase the length, it makes the embeddings more similar. what we should do is to modify the entire text itself based on context. So I show you the other example for finance. Okay, we look at the finance one here. So in finance, nothing changed here. Okay, I mean, other than when become visited, but you can see that this one, yes, is a very low similarity. But if you look at this, I went to the bank, I went to get money. This actually becomes, okay, a bit lower, yes, but you know, this is still reflective of the fact that, you know, it's more similar than like going to the river. So this, at least, it's a plus. So by shifting the original text based on a certain context, I store the embeddings in a different way. And this different way could help us to compare things based on context. So like if your one context could be like action space, one context could be location and so on, you know, you could extract out relevant parts of the text for comparison later. So I mean, one of your contexts could also be entities, you know. Any questions for this? Because I think this is the approach that I would like to pursue, and it looks like it's performing well. Yeah, and
how would you like us to help you to test it, like for a bigger document? I mean, this looks great.
Sure. Yeah, I could just put this in default in strict JSON, and then you can try to test it out as an expansion. But the idea is, instead of storing one abstraction space, we store multiple abstraction space for the chunks, for your maybe your documents. So if let's say your query is a query about entities, then you can use the context of entities to compare and find relevant chunks. If your query is something about location, then I will just use the location context and compare the text chunks. And the good thing is we can pre-store this context-dependent text chunks already. So every time you have a text chunk, so let's say you have a text chunk you want to store, you pre-process it to embedding space 1, 2, 3, 4, 5, 6. So you already store all these spaces, something like that. So embedding space 1 could be this. So this is embedding space 1. Oh, sorry. Embedding space 1 could be this one. This is embedding space 1, the bank. And riverbank could be embedding space 2. I mean, the whole sentence could be embedding space 2. And, you know, because when we do this, we actually don't need to keep doing this for every document. Because if your contexts are fixed, you can just run it one time for the new document. And we can really pre-store all these text chunks into this multiple abstraction spaces, so that once we do the final embedding comparison, it's just a cosine similarity. So it's still using cosine similarity in the end, but with updated embedding spaces. Yeah, so maybe I just pause here for 5 minutes if you have anything you want to talk about on this slide.
I guess I wanted to try, I mean, I think that's a really good approach. Like, it's really interesting the way that it, without changing the context size, you give it better meaning. Like, that's like, that really works. I'm a believer. Right? I'm sort of toying with a sort of maths rather than a language-based approach on the side. Like the idea of, we're talking about image search, right? And increasing specificity and scope and so on as you search. And the idea of building additional, like basically quantized embeddings. So they would give you deliberately a much less rich information model, but you could easily go up and down those chains, right? So my embedding at a token level is X, but if my first sort of pass where I drop out half the tokens, right, and they just get merged, they all get merged one into the other. If they're close enough, and it can pre-calculate it and so on and so forth. So you have these relatively small spaces to look for similarities in. The problem is I haven't finished that idea, but it's another approach to, in my head at least, to the same problem. Right? The problem of how do you, because if you have those quantized embeddings, right, you don't need to reduce it to a single value, or it becomes a coarser evaluation deliberately. So you will often end up with larger or a different cosine similarity if you look at them, and you're not limited to a single value. You can, because it becomes more tractable, there's less options on the table. You've got different approaches than just cosine similarity. So I'm
in
just
fact,
trying to.
it's like cosine similarity on steroids. Like you have a lot more avenues you can do cosine similarity on because you have more dimensions, like more domains that you can
but each domain is hopefully much simpler than the last.
Of course, yeah. So if we look at the earlier slide, I talked about the text embeddings. The longer, the less, the more similar, right? So the key insight that I got is that we should try to make these embeddings as short as possible.
Yep. Okay.
Yeah. So I think there's a lot of lessons that can be learned here. This is not found in any modern research paper because I think people haven't really reached this idea of multiple abstraction spaces yet. But I strongly believe this is correct. So I'll be testing this out, and then like if all goes well, you all see a paper soon, or it might just be in the product. Yeah. So we see how it goes. Yeah. Okay.
So I have many documents. I mean, what's the workflow to help you to test this out? Because it sounds to me that I need to read through the whole document and to highlight and identify and group those categories of context before I submit it to the model, right?
Correct. So like for every text chunk, depends on how you want to group your text chunk. You can go by tokens, or you could go by like sentence or paragraph. Each text chunk, instead of storing it as one embedding space as what we do now, we will use this text conversion function to store it into multiple contexts. And I mean, what are your contexts? It really depends on what your use case is. So if your use case is about entity, finding out entities, then the context could be like highlight entities. Or if your context is about actions, then it's like highlight actions as your context. Or your context could be finance, then you could convert the whole thing to finance. Yeah, so you need to do this pre-processing first. And instead of just storing one vector, you store multiple vectors. So for example, your text chunk is like, this is paragraph A, right? The traditional approach is that you store this using an embedding model, you get embedding A. So this is the traditional approach. Okay, but what we will do for this is that instead of just having paragraph A, okay, we will have converted paragraph A1, all right? And we also have converted paragraph A2, and so on. And all this, and many, many more, all this will be stored into different embedding space. In fact, this will be stored into embedding space A1 and A2, and so on. So when you extract out your documents, if there's a match in your query, so your query will be here. Okay, your query would actually also be converted query. So you also convert your query into maybe the same space as your paragraph by infusing the right context. Okay, we'll get an embedding space, like maybe we call it Q1 and Q2. And I haven't really figured out how to do this matching yet. I mean, it could be for each, maybe it could be for each query. Okay, like Q1 will look into all the A1s, or look into all the ones, and Q2 will look into all the twos, and so on. And then you just take the top K for each. Or you could do some other method. I mean, the idea is you have multiple query embeddings, you have multiple paragraph embeddings, and then you just do your magic, whatever algorithm you want to use to extract out similarity. The idea is, because I give you more such abstraction spaces to begin with, you lose less information, and the chance of you finding the right match will be much higher than just giving only one abstraction space.
Okay, I see. This is probably something that needs to be productized for large-scale deployment, right?
Correct. So I can only tell you which one works after testing it out. But even so, I think the idea of multiple abstraction space is correct. Yeah. It's just a matter of how to do this architecture. This can be refined later on.
Cool.
Of course, if you have the money and bandwidth and latency bandwidth, this is still like considered second class. Okay, what's the first class method? Is what I showed earlier. You put everything into the transformer and then ask the transformer to output the answer. So if you can put the query and the paragraph together into one large language model and ask the large language model to output similarity, hands down, this will be this approach as well, because the large language model has all the context you need. Okay, but if you don't have that luxury, this is the next best. Yeah, so anyway, this idea that I'm sharing with you today, I've never seen it done anywhere else before, so you are probably the first ones to hear it. Yeah, so this is I would say just an idea that I have, and I think this idea would work.
Yeah, so far it looks really good.
Yep. I mean, y'all can help to test it out, and then we see how it goes. If all goes well, we can write a paper on it. Yeah. I'm not very interested in writing papers. I'm more interested in getting it to work. So if it works, then the paper can come naturally. Yeah. That's a second consideration that I have. Okay. Sorry, it delayed a bit. But let's spend like maybe the last 5 minutes to talk about some questions. So the first question is, should we do the similarity search using cosine similarity by embeddings, or feed everything into a transformer? Okay, I think I've given the answer just now. Like, I prefer the second approach, but it's more expensive. Any other comments for this first question?
I still dream of a sort of embedding maths sort of space solution, but I think certainly on the today view of the world, what you're doing there with context is a better solution because it works. I think there's no reason why it can't work.
So you are more in favor of the slide that I shared earlier on this approach, right? You are more in favor of this.
Something. So this is this approach to modified text based on context. That feels like that's nice and flexible and versatile. It's still prompting based, which we've already talked about. But
yeah, so you want an approach that is totally trained from scratch.
Yeah, I'd prefer something a little more fundamental, but I don't have one to hand either. So you've got a thing that looks like it's going to work well.
Yeah, we have to test it out to see whether it works well. Yeah.
And the way you've got it set up is you can pre-process everything as well. So it sort of depends on facilities, which are pretty easy to get a hold of. Right? A big database index and pre-processing documents. Sure, that's easy to do.
I think it can be implemented quite easily, actually, this approach. It's just whether it performs well. All right. So next, is there any way to get the sentence embeddings to perform better by adding context to the embedding? So I would say yes. Okay, so you can just look at the experiments that I did on context-dependent embeddings. And also, like, I think hypothetical document embeddings or like hint-based guidance could help, okay, with the embeddings becoming more and more like towards that domain. And I use this hint-based guidance to do the context-based guidance as well to make the embeddings closer to the context. And one key thing to note is try not to add in more information into the embedding into the text itself, because two similar chunks of text equals a high embedding similarity. Initially, my idea was just to prepend or append the context, but it didn't work out too well. So the next best method is to change the text by context, and that's exactly what I showed in experiment 2. Any other comments for this question? Okay, I think we discussed quite a bit on this just now, so all's good. The last one, okay, this is a very interesting thought I had in mind. Like, because some people like to search by keywords. Okay, what are the keyword search methods? TF, IDF, term frequency, inverse document frequency, or BM25, which is a similar approach where you like how keyword matches and find documents with higher keyword matches. Will this approach do better than embedding matching? Okay, so maybe I give the context. The context could be the queries are about entities. Like, you want to find out more about what did John do, which school did Mary attend, that kind of stuff. Would matching by keywords do better than embedding similarity matching? So I just open the floor for some discussion before I give my thoughts on it. Anyone has any thoughts for this?
Yeah, I think for medicine, And for legal, that has very singular, you know, tightly defined meanings that will work better. But for other fields that is subject to interpretation, I don't think this will work too well.
That's right.
I was going to go on the same thing. You know, I find keyword searches work very well when you have a term which is almost unique. Doesn't matter what it means. That text string doesn't exist in any other context. Highly efficient, great. But if you want to search for, say, John studying PhD, like, they won't help you very much.
So I actually agree with both of you. In situations whereby the exact terms would repeat again, like medicine, like if you have a hypothermia, that word will appear, and the context is similar. Like it doesn't really matter what context it is. Hypothermia is hypothermia, right? Or like blood clot. I mean, that one might have different context. But the thing is, if you search like blood clot and you match the documents with blood clot, chances are you'll find the right documents already. So if your domain, if by keyword search, most meaning is there, then keyword search may be better. Because if you do by embeddings, you might actually lose some of the meaning, especially for long sentences. You might lose some of the meaning of that keyword. Okay, and the fuzzy keyword match might not cut it. Like blood clot versus like maybe hemorrhage for medicine terms, might be totally different things. But because they might mean something similar, if you use the embedding similarity, you might get something close but not exact. So like if your domain, if exact match is absolutely needed, keyword search may be better. Okay. But you know what? If we were to do the context dependent embeddings, you can actually extract out the entities. You might actually do just as well or even better than just the naive PF-IDF or BM25 metrics. So I would say that this idea of multiple abstraction spaces with different contexts is very powerful. I don't have the full answer to it, but I'm betting that this would work. Okay, so this is something that I'm keen to try out. And if you're keen to help me try out, I will give you all some of the pipelines to run this. You can see whether it works. All right.
Yeah, sure. So this one does not require changing the model, right? Or like, re-architecture or we train the model, right? This will just go with whatever we have, right?
Yes. So whatever you have, you just need to embed instead of storing, like, for example, every key. So normally what you do is you store your text chunk, right, as your key, and then your embedding as your value. So now instead of storing it only like that, you need to change it to like that: text chunk as key, or actually, sorry, normally it's the other way around: embedding as the key, and then text chunk as value. Right? Now what we do is we will have embedding 1 as key, text chunk 1 as value, and then like embedding 2 as key, having 1, okay, maybe we call it 1A, 1B. So instead of like embedding 1 as key, text chunk 1 as value, we need to store like that.
Okay.
Yeah.
I see.
Or actually not 1B, just put the entire text chunk itself. Like, yeah, you can just basically one text chunk has multiple embeddings. Yeah, so when you do your retrieval part, many embeddings would map to the same text. Yeah, so that's the difference in terms of interpretation, right? In terms of how you actually do it. But other than that, the way you do cosine similarity is the same. Like you're still taking 2 embedding vectors and do the similarity.
Okay. Yeah, I'm still not 100% clear of the workflow if I have multiple documents and they have multiple paths where they relate to each other, and how would that work across many documents? Because in organizational communication, you have an imperative, and then you have different streams into different departments, and they all related. But I guess as we move along and look at your paper and your examples, we can figure that out.
I don't have a
Yeah.
paper yet. I mean, this is very preliminary. I was just playing around, and this kind of works. So next up will be taking some real world data set and see whether it works.
Yeah, but it looks promising though. Yeah.
Okay, if not, thanks for sticking around. Any last words before I end today? All right, so I think today's session is very interesting and also very futuristic because we are talking about a lot of future possibilities that haven't been done yet. And yeah, I do hope that this kind of context-dependent embeddings will take off and will be the default rather than just a single embedding itself. All right, so and that's all for today. And see ya.
Thanks, guys.
See you. Thank you.